Hello, and welcome to this session on Builder's Design Pattern. The Builder Design Pattern is a creational design pattern that is used to create complex objects step by step and allows you to produce different types and representations of an object using the same construction code. The main idea behind the Builder's pattern is to separate the construction of a complex object from its representation so that the same construction process can create different representations of the object. The builder's pattern can be particularly useful when you need to create objects with a large number of optional parameters, as it allows you to specify which parameters to use and in what order, without having to create multiple constructor signature. This video is part of a 20 hours Udemy course where we cover hundreds of real-world design pattern scenarios. Hello and welcome back. In this example, we will be implementing a real-world SQL query builder using Builder Design Pattern. The SQL query builder will be used to construct different SQL query. SQL query typically has several clauses such as select, from, where, group, by, order by, and limit. The query builder class allows this clause to be added incrementally, making the construction process more manageable and readable. Let's take a look at the sample code. We're going to start by implementing a class called the query builder that takes in an attribute underscore query that is set to none. This is a string where all the query statement will be stored. Next, we're going to implement methods that does the select, the from, where, group by, limit, all the clauses of the query. Let me take this up. And let's create the first clause. It's going to be select. The select clause takes in the string select, and then it uses a join to put together all the database fields that we want to include in our select statement. The return self method gives us back the query builder object. Next method is to create a from clause. And so we're going to create a from method to handle that. And the from method will take in a table. It's going to concatenate from whatever table that we have stored there. And then it returns back the query builder so that we can chain other clauses to it. The next clause will be the where clause. And the where clause will also concatenate where and use a join method, because for where we can have multiple conditions that we specify in our where clause. To make this clearer, I'm just going to specify a type inting to say that the column is a list. I'm importing the list type. And then also the condition is a list. And that is why we're able to use the join method on them. We can also create order by and group by. Order by will do the same thing just like we did with where. It takes in a list of columns and then it joins them together separated by commas. And then we also have a group by, which does the same thing by building a query using the list and then concatenating with the query string attribute. And lastly, we have limit, which just concatenate the last word, limits, and put the limit there. Now let's return the generated query using the get query method. We're just going to start the usage by instantiating the query builder and then using the query builder to generate a special query. The first one I did is a select query that took in 2 columns. And then I changed in the from query. And then also I'm going to chain in the where method. The from method will create the from query. And then the where method will also create the where query. And then I'll create the group by query, passing in a list. As you can see, this takes in a list. And then also I'm going to do the order by query that takes in another list. And I'll also run the limit to set limit for the query. Now this generates the query string, and to get back the query string, I'm going to also call the getQuery method that returns the string that is generated. I can run the output of this code by running the print method to print out the query, and you can see here, because we did this, we were able to chain queries together, and here we have the query generated. If I take out the order by, you will see that the order by query will be out of it, and you can also take out the limit if you want, and the limit query is also out of it. So I can generate my query using this chain of query generators that gives me a chain of query using the builder pattern. This builder pattern style allows me to generate different query representation by chaining together different query clause methods from the query builder. Hello and welcome to this section on factory method design pattern. What is factory method design pattern? The factory method is a creational design pattern that provides an interface for creating objects but allows subclasses to decide which class to instantiate. It is a type of object-oriented programming pattern that promotes loose coupling and adheres to the open-close principle, which states that classes should be open for extension but closed for modification. The factory design pattern is useful when you want to delegate the responsibility of object creation to subclasses, rather than having the base class directly create objects. This allows for greater flexibility and extensibility, as new subclasses can be added without modifying the existing code. By using the factory method pattern, you can encapsulate the object creation logic within subclasses, providing a consistent way to create objects while allowing for flexibility and customization. This pattern is often used in frameworks and libraries where the exact object type needed is determined by the client code at runtime. Hello and welcome back. In this real-world code example, we will create a document processing skeletal app using the factory method design pattern. The code will create different document types such as Word document, PDF, and HTML files, and open them using an open method operation. The first thing we'll do is to declare the abstract class that we'll use to create the interface for the document type. And as you remember, this is the product, and then we'll create other concrete class of the product. So we create a document and it implement this operation open, which is a method for the documents. And then we have classes that implement each document type. The first will be the Word document, and the open method we just print out opening Word document, and the next one will be the next document type, and it's going to be PDF, and it's also going to show opening document type. And then lastly, we have HTML document. We're going to create the creator, which is the document factory that will enable us to create each of these documents. And we'll start by implementing the interface, the abstract class, which defines the contract. The document factory is the creator of the products. The create document will return a document object, which actually creates each of the documents. So, and we're going to start by creating the first concrete class for the creator, which is document factory. And this class will create a Word document. You can see it uses the creator method and returns a Word document. And we're also going to do the same thing for the other to the PDF document factory. We create a PDF document. HTML document factory will create an HTML document. I'm going to have the client code, and I'm going to start that by creating a method, and that method takes in a document factory is going to take that document factory and calls its create document method. And then also the document that is created has an open method. And then so we're going to call the open method of each of the documents. So this code we run for all the implementation I want to make. I'm going to start by calling the first document factory, Word document factory. I'm going to pass that Word document factory to the process documents method, and that will create the document and then open the document. I'll do the same thing for PDF, and the PDF will create the PDF document factory and then pass it to the document process method for creating the document and opening it. And then I'll do the same thing for HTML factory and create the HTML document. If you open this in the output, you will see that it created the Word document, opened it, created PDF and HTML document. So we were able to use the factory classes to create the documents instead of directly creating those documents. And if we want to add a new document, we can just simply add that document here, and then of course create it appropriately in the factory and also in the client code. Hello and welcome to this session on the Abstract Factory Design Pattern. This video is part of a 20 hours Udemy course where we cover hundreds of real-world design pattern scenarios. The Abstract Factory Design Pattern is a creational design pattern that provides an interface for creating families of related or dependent objects without specifying their concrete classes. It separates the process of creating objects from the actual implementation of those objects, allowing for greater flexibility and ease of modification. It is often used when a system should be independent of how its products are created, composed, or represented. It is similar to the factory method, only that it creates families or groups of objects instead of a single object like factory method. Hello and welcome back. Let's take a sample code of implementing Abstract Factory Design Pattern. To showcase this example, we need to remember that Abstract Factory groups together different products or families of similar products together. In this instance, we will be creating two types of houses. We will fill these houses with groups of products, which in this case are house amenities like furnitures, electronics, and decorations. Each house, either a big house or small house, is filled with its own befitting amenities. To start, we will create three different product types, which are house amenities in this use case. The first product will be a furniture, the second an electronics, and product 3 will be decorations. Each of the products are abstract classes of house amenities. They define the contract for specific concrete products or amenities we will be creating. Now let's start by creating different furnitures from the furniture abstract class. And as you would note, we also pass in the quantity of the furniture and then also a display method, abstract method, to display the information about the product, in this case the furniture. So we're going to create two more furnitures, and as you can see here we have chairs and sofa, which are subclasses of the furniture abstract products, and each of the subclasses also implement display method. Now let's also do for the second product, let's have two more products that subclasses that implement the electronics interface. For electronics, we have radio and television, which are subclasses of the electronic contract. And for the third product, which is decoration, we're also going to have two subclasses that implements the decoration abstract class. And you can see flower vase decoration and chandelier decorations. So altogether, we have 6 different products grouped into 3 different types. Now let's go and create a factory of products. We are going to create a factory class called house factory for building different house type containing different house amenities. The house factory is an abstract based class and is used to build furniture for a house, electronics for a house, and decoration for a house. Now we're going to be subclassing the house factory to build different types of houses. Let's start with building a small house, and a small house will also inherit all the methods that the superclass, the abstract based class, has, because it implements the house factory. And we're going to be calling products of each of these house amenities that befits a small house. The furniture method we'll call the furniture product, and this time we're calling a chair, which is a furniture that has 4 items. And then we're also going to be returning for the electronics 2 radios. And for the decoration, because it's a small house, we're going to be returning a flower vase, and there are 4 flower vases in the small house. And we're going to implement another house, but this time it's going to be called a big house. And the big house will also implement all the amenities, that is all the methods that it inherits from the house factory. And also for each of the products, it will return a type. So we have, for furnitures, we have sofa, 10 sofas, electronics, we have television, 7 television, and decoration, we have chandeliers. For the client code, we're going to have a method for taking in a factory, whatever house, maybe a big house or a small house, and then calling the methods for each of the house and returning the amount of houses, and then calling the display method of each house amenities or product it gets to return the information concerning the house amenity or product. So when it gets a house factory, then it's going to take the furniture of the house factory and run its display method, and then also gets an electronics and returns the display method, and then do the same thing for decoration. I'm just going to put a print method here so that it prints out an empty space. Now let's create a small house. This is just to print out that we're creating a small house. I'm going to open up the output window, and then I'm going to call the client code, and the client code will have a small house inside it. And you can see for a small house, it gives us the number of furnitures, the number of radio, and flower vases. Those are the products that a small house will create. And then let's do for big house that we implemented. So I'm just going to put out a printout there, and then run the same client code but pass in a big house object. And then you can see for a big house, it shows that we have 10 sofa, 7 television, and 4 chandeliers. With the abstract factory pattern, we are able to group together different product families, as you can see displayed here for a small house and then also for a big house. This video is part of a 20 hours Udemy course where we cover hundreds of real-world design pattern scenarios. The course is called Design Pattern in Python with real-world code examples. We showed via practical coding how design pattern is implemented in real-world scenarios like event manager, catch, database connection codes, document management code, creating optimized configuration settings, login frameworks, GUI framework codes, plugin systems, game development codes, payment gateway, document generators, computer graphics generation codes, financial model code pattern, resource pooling, object pooling in ORMs, website creation, database query codes, language translator, web application framework creation, banking system codes, organizational chart creation, file system, interpreter, menu system, text formatting code, authentication code, authorization code, API for OS, document management system, create proxies, event handling, middleware in web development, workflow system, undo redo functionality in apps, job scheduler scenarios, parsers, chart applications, drawing applications, notification system, distributed system, booking system, workflow management system, sorting algorithm, file compression utility, and many more. If you are really serious about your career in programming, you have to get this video, and you don't have to be a Python programmer to use it. Use the link in the description to get the best price for this course on the Udemy platform. Hello, and welcome back to this session on Object Pool Design Pattern. What is Object Pool Design Pattern? The Object Pool Design Pattern is a creational design pattern that manages a pool or a cache of reusable objects. Its aim is to improve performance and resource utilization by reusing objects instead of creating new ones. This pattern is particularly useful when the cost of object creation, initialization, or destruction is high. In the object pool pattern, a pool of objects is created and managed by a pool manager. When an object is needed, instead of creating a new object from scratch, the pool manager provides an existing object from the pool. When the object is no longer needed, it is returned to the pool for future reuse. This way, the overhead of object creation and destruction is reduced. By reusing objects from the pool instead of creating new ones, the object pool pattern can improve performance, reduce memory consumption, and minimize the overhead of object creation and destruction. It's worth noting that the object pool pattern should be used when the cost of object creation and initialization is high and the number of objects needed is variable. If the number of objects needed is fixed or low, the benefit of object pool pattern may be diminished. Hello and welcome back. In this example, we're going to implement a connection pool system using the object pool design pattern. And we're going to start by importing a random time module, and then we'll also have a connection object that instantiates a connection and set the connection to false. And then the connection object is going to have a connection method that connects the connection object that sets its connection to true. Basically, we're just simulating this. Connection set to false means there is no connection, and connection set to true means there is a connection. And then we're also going to have another method to disconnect the object, which will say disconnecting from server, and then will give us a little moment, and then we'll set that connection to false. So basically, the connection object will use the connect method to set connection to true, and then the disconnect method to set connection to false. The time sleep is just to help simulate connection. And then we implement the connection pool manager that takes in the maximum connection that we want to have at a time and instantiate that connection. And also it's going to take in two variables for keeping the connection that are available and then the connection that are in use. And then we're going to be setting those connections. So right here, the moment we call the connection pool manager, is going to set for us whatever number of connections we have. It's maybe 2, 3, or 4 or 5 connections. It sets those connections for us into the available connections list. Then again, we run the acquire connections method, and the acquire connections will check if there is any connection that is available in the connection list, and if there is, it's going to pop out that connection. And because that connection has been popped out, it's going to store. It's been popped out, and that means it's no longer available in the available connection method. So we're going to store it in the in-use connections, and then we change the status of that connection to connect, and then we return the connection. And if there is no connection, or if there is no available connection in the list, then it should return that no connection available in the pool. So it only uses the amount of connections that we have for the pool. And if we want to release a connection, we do the method release connections. And basically, what we need to do for that is to reset the connection to how it was. So we use the disconnect method to reset the connection, remove the connection from the in-use connection, and also add back the connection to all the available connections. So when we are not using it again, it removes it from the list of in-use connections and then put it in the available connection list. Let's implement the code here and instantiate our connection manager, and then let's acquire two connections, con1 and 2. So here we use the acquire connections. Actually, the moment we start acquiring connection, it's going to run through the connection method of the connection, and that changes the state of the connection to connected. And of course, we should be seeing this output. Let's run this output from the code here. I think it's gonna make more sense because we're using timer. So I'm gonna run that code, and you see it's saying connecting to server, then connected ID2, and then connecting to server for 1, and then connected ID1. So because we ran for 2 connections, it has connected for the first connection and the second connection. Then I'm going to run a print to use the connection just to be sure that these connections are available. I'm going to call their IDs. So I'll call the print using connection, and then just wait for a little time. And then let's say this is going to a server to pick up some stuff. And then I'm going to do the same thing and use the second connection. And that will also show that the connection is available. So you can see I'm using timer to hold the time that the processes are done. Now let's check the connection that is available. I'm just going to put in a print command that prints out the available connection. It gets the length of the available connection list, and then the length of the used connection list. And if we run this code right here, you're going to see that it actually connects to the servers, the first and second servers, and then it shows the available connection and the used connection. Because we use 2 connections, we have available connection being 1 and the used connection being 2, because we actually acquired 2 connections here. Let's now release these 2 connections that we've already used. We're going to do that by calling the release connection method of the connection manager. So we release the first connection, and then we release the second connection. So now those connections are removed from the used connections, which are 2, and then pulled back to the available connection. Now let's run this code again so we see what output the available connection will give. So I'm just going to do that and run that again. And you can see it does the first and second connection, and then use those connections, released, say the available connection is 1, and then it disconnected those connections. Use the disconnect method because we're calling the release connection. Use the disconnect method to disconnect the connection 2 and connection 1, and then it says available connections are 3 and used connection is 0. So with the object pool design pattern, we're able to manage the use of this connection. We instantiated 3 connections with the connection manager. We acquired 2. We use the time, sleep, and random to simulate activity with those connections, and then we check the connections at the point where we use 2. We had 2 connections being used, and then we release those connections, and then it shows that no connection is in use and available connection is 3. Hello, and welcome to the session on Singleton Design Pattern. The Singleton Design Pattern is a design pattern that ensures a class has only one instance and provides a global point of access to it. It is often used for objects that needs to be shared across the entire application, such as login, database connection, and configuration settings. The basic implementation of the Singleton pattern involves creating a private constructor, a static instance variable, and a static method that returns the instance. The instance is created the first time the method is called, and all subsequent calls returns the same instance. This ensures that only one instance of the class exists, while still providing a convenient way to access it. Hello and welcome back. Let's take a real-world code example of a database connection application using Singleton design pattern. And in this example, we're going to start by first creating a non-Singleton database connection, and we will need two dependencies to make this work, and that will be a database, a MySQL database installed, and also a Python. We do pip install MySQL connect on Python, which is a module that helps to connect to the database. So, and having done that, I'm going to import the MySQL connector, and then I will create a class, which is the class for creating the database, and I will initialize this class, and I'm going to first print out, do a printout that says initializing a database connection, and then I will then connect to the database and store that connection in a connection variable. So I have self.connection, and it uses MySQL connect to connect to the database. I have a database called HRM, it's the username and password, and it's stored on my local host. And haven't done that, I'll just print establish. So basically, it's connect to the database, it tries to connect to the database, and when it does that, it's then print establish. Yeah, I'm just going to do a delay of the print. Let me import the time module and then sleep for just like 2 seconds so that it will simulate time delay during connection. So let's take a look at this code right here. If I run this code, it's going to attempt to connect to the database. I'm also going to run define a string method that returns the connection. And then we create two connections to the database. On initialization, it creates two connections. And I'm also going to print out to check if the two connections are the same connections. And also I'm going to do one more, two more printout to print out the connections. That is to see the memory address of the connections. And also I'm going to close the connection eventually. Let's run code. So I'm going to open it up a little bit more. And as you can see, the connections connected to two different instances of database. But if the scenario you want to create is to have just one connection instance to your database, then you will need a Singleton. Singleton will help you to reduce memory waste that result from creating different connection instances on the database. With a Singleton implementation, a 100,000 database connection can use one connection instance instead of the 100,000 connection. That's a lot of memory saving. Now let's turn this code to a Singleton database connection. And the first thing to do is to create a class instance variable which stores the only connection that will be needed. And then I'm going to create a get connection method, which in this case will be a class method. The get connection method is what we will use to connect to the database. And the first thing I'll do with get connection is to check if the instance, this instance that we want to use as the only connection to the database. If it is none, that is, if there is no connection to it, then it should create the connection. This calls the init method and it creates the connection for the first time. And having created the connection, we then store that instance that is created back to the underscore instance in the init method. That is, when we call the get connection, it checks if there is an instance initialized here. If none, it calls the database connection class, which calls the dunder init method, and the dunder init method then populates the underscore instance variable. So the next time we call get instance, the first time is going to help to create the underscore instance, but the next time we call it underscore instance is no longer none. So it's going to jump this code and then just return the content of the underscore instance. So right in our code, this initialization, this process is okay to create a singleton if we keep calling get underscore instance, but a hacker may want to just call directly the database connection method by themselves. And to stop that, we're going to have to then to have a condition that checks if, before it initialize, it checks if there is a connection existing. So if there is a connection existing, then it should raise an error that a connection already exists. And if no connection exists, that's when it will implement this part of the code. So we won't be calling database connection this way again. We're going to be using the get connection method to call it. If you call it this way, it's going to instantiate the first one, and then the second one is going to throw an error. Let's just try it first. If you call it this way, it's going to start and instantiate the first one, and you can see, but the second one, it throws an error that connection already exists in a singleton. So to be able to use different connections, we're going to be using the get connection class method to get the connection. So I'll say get connection. So it's going to create just one connection, but it's going to assign that connection to maybe somebody somewhere wants to use it. So right now, let's run the code again. What you see here is that it only connects to one instance of the database. It's not doing two connections anymore. It connects to only one instance of the database, and it assigned that one instance to the second connection. So everyone is using connection 1. And there won't be need to close connection 2, because the moment you close connection 1, which is the only existing connection, the system will close all the connections. If you have 100 connections, just closing connection 1 will close everyone, because everyone is using connection 1. So to create a database singleton, all we need to do is to create the instance that holds it, that holds the first object created. We use the get connection method to create the object. When we get a connection, it uses that one connection to connect to every other connection that we want to create. Hello, and welcome to this section on prototype design pattern. The prototype design pattern is a creational pattern that creates new object by copying existing object rather than creating new object from scratch. This can be used when creating new object is computationally expensive, or when creating new object requires a lot of complex configuration. The prototype pattern involves creating a prototype object and then making copies of that object as needed. This video is part of a 20 hours Udemy course where we cover hundreds of real-world design pattern scenarios. Hello and welcome back. Let's take an example of using prototype design pattern for creating web pages. A website may have a number of pages that share a common layout and design, such as the header, the footer, and navigation menu. Instead of creating each page from scratch, a prototype page can be created with the common elements, and then copies of that pages can be made as needed, each with its own unique content. Let's take a look at how to do that with the prototype pattern. If you remember our last example, the first thing to do when creating a prototype is to have the object you want to duplicate, the object you want to do prototyping on. So you have the object to prototype, you have the prototype class, that's the prototype engine that has objects that you want to prototype, and then also you have the register object, unregister object, and the clone method. This is the template we will use to create the web page example. Let's start by creating the object to prototype, and that will be our web page. That's the object we want to create again and again. Let me put import here as we did the other time to help me do the cloning. Now let's go to the prototype engine, the prototype class. I'm going to call the object pages, or just call it page. That is a dictionary, an empty dictionary. Now to register every instance, what I'll do is I'm going to say self underscore page, and that will take in the object. And of course I have to specify the key, which is the name. And also to unregister it, I'm just going to do delete self dot underscore page. What are you deleting? Deleting the name. So here I register any object created, and here I delete that object. Now to create the clone, I'm going to call, to make it more intuitive, I'm going to call this register page, and then unregister page, and then I will call the clone create page. This is where you create the different pages. The page, the object that will be created, I'm going to call it web page, and then I'm going to do a copy of that object, deep copy that object, and use the get method to take the specific object that I want to deep copy. If there is no object here, it's going to return none. Let's do web page. Let's update the dictionary value, that is all the variables that are attached to the object, the pages. We have updates, and then let me make this contents. These are all the contents. So I'll call this contents, and then I'll return the web page. So right here we have the engine created. Let's go back to creating the web page. The first thing I'm going to do is to initialize the web page and create a header. Call that none. I'll create contents or body. Let's say contents. Call that none. And then also create a footer and store none in there. Then I'm going to create a method that returns a page. And that method returns a literal string containing self.header and the footer, the header, the contents, and the footer. Yeah, this is basically the web page. When you create a web page, when you call the page method, it returns the web page. But I want to make it a little bit more flexible web page. I would like for the content to be not just one variable. I want the content to have, multiple content. Maybe I would like to create different paragraphs. So I don't want it to be just one content. Well, this is out of the scope of this class, but it's a simple way to do that. I'm going to say define contents. Yeah, I'm going to take this out. I'm going to make it a method. And then I'll return the content of the dictionary, the header and footer, and whatever thing that will be in between. I would do the methods to create all the other variables that will be in between. But right here, to get the content, which was content here, which was none, what I'll do is I'll say use the join and then create the web page. I'm accessing the objects and getting all the items in the object, but I want it to remove all the header, because I've already specified the header, and then remove the footers from it. So this get everything in between here. For instance, I have say self the paragraph, which has some content in there, self the people, which has some content in there. So basically the headers and the footers are always the same thing. So I'm just trying to create a way in which we can flexibly get all that data out. So I'm going to delete this, and to do that I'll just say set the pages. That is how to create all those middle pages, which will contain the type of content and then the content itself. This is just creating the object, and then I will set the attributes to the type of content and then the content. So technically, this is what needs to be created, the object that needs to be created, and this is the prototype that does the creation. Now let's create an instance of the web page. I want to make that the home page, so I'll say web page. Now I have that instance, and if you want to see the content of this instance, you can come and look at the DunderDict method of the instance. Let's run the DunderDict, and right here you will see it has header is none, footer is none. This is because that's what we declared here. We have the header and then footer being none. If we want to put stuff in the header, I'm going to come here and say home dot set page. I'll say that should be a header, and then I'm just going to do let's say home header. All right, so if you check this out now and I run the code, you will see header now has home header as its content, while footer has nothing. So I can do for footer too, footer, and say home footer, so that footer too can have content and not none. This is home footer. Now the beauty of this is that now I can also create more contents. I can come in here and create for another home and say introduction. Let me use a copy of this. Will be home intro. So if you run these again, you will see there is header, there is footer, and there is introduction. There is home intro. There is a key for introduction. So you can have different stuff there. If you look at the DunderDict here, it's going to show you that each of these items, the keys are created: introduction, management, product keys. On a usual web page, is the header will be the first, the footer will be the last. Every other part should be in the content. That's why we used the content method to create the contents, to create more like creating the content here. So we can have several content being created. You can actually use the page method to print out the header, the content, and the footer. So if you print this out now, you're going to have home.page should print out. It printed out the header, and then it printed out method address. That means we should have added a bracket here so that it can print out the real content. Let's do that again. Okay, right now you can see, let's divide it. After the asterisk, after this, you have the home page. So we have the header, and then every other thing, the management, the product list, then the last part is the footer. So having done that, we can also create another page from the home page we just created. Let's use the prototype method to clone this home page. Now that we have a home page, the prototype method. Okay, let me change this to page maker. That's the name of the prototype method. Instead of using prototype method, I'm just going to call it page maker. Let's call it PM, and that will be page maker. And then we register the page maker, register a page, call the page home. That's the home page. And then, of course, put the home object. So the PM is registered. Now, if I want to clone the object to create another page, all I'll do is say PM create page. The create page is the clone, and then I will be creating the page from the home, and I'm going to store that to about us. Let's just say about. So now a new page is created. Using the create page, a new page will be created. You remember, I can also specify initial contents here. The create page allows me to specify initial content. So what I can do is change the header, about header, change the footer, about footer. Now let me print out the about us information. I'm going to print about page. So when I run this right here, you will see the about page now has the header being the about header. It has all the intros, the product list, management stuff that already is part of the initial page. And then the footer also was changed. So right here, I'm using the prototype methods to clone the about us page, still having the same templates, having all the other content that I want to sustain. I can come here and also still use the set page for the about us, and maybe change the management content to about us management. So we have the about us management here, but what is important to note is the page maker allows us to clone the web page that we just did. You can implement your own web page in your own way and use this page maker, which is actually the prototype engine, the prototype class, to duplicate or clone. This is where we did the cloning. We registered the object that we want, and then we cloned it here into the About Us page. And then, of course, if you want to clone the About Us page, you just do the same thing. You register it, and then you also clone it. You can have several registered pages and then clone them in different pages or different locations or sections that you want. This is this for web page creation using the prototype design pattern. Hello, and welcome to this session on Adapter Design Pattern. This video is part of a 20 hours Udemy course where we cover hundreds of real-world design pattern scenarios. Let's take a look at the introduction. The adapter design pattern is a structural pattern that allows objects with incompatible interfaces to work together by creating an intermediate adapter object. The adapter object translates the interface of one object so that another object can understand it. In other words, the adapter pattern helps to convert the interface of one class into the interface expected by the client. This pattern involves creating an adapter class that acts as a wrapper around an existing class, providing a different interface to the client without modifying the underlying code of the original class. The adapter pattern is useful in situations where you have existing code that cannot be changed or modified but needs to be integrated with new code or systems. By creating an adapter, you can make these two systems work together without the need for extensive refactoring or rewriting of code. Hello and welcome back. Let's take another example, a real-world example of an audio adapter. The purpose of this example is to implement an adapter that adapts external audio player engines or module to an existing media player module. We're going to call our existing media player engine audio player class. This uses its play method to play audio with different extensions. At the moment, it can only play MP3 and WAV files. Any other extension will throw a value error saying that it is an unsupported audio type. We want to extend our audio player so that it can play other types. So we brought in an advanced audio player, which for now can add MP4 to the music type we can play. It uses its play MP4 method to play MP4 audio. We will now need to integrate the advanced audio player to the existing audio player. The challenge, however, is that the advanced audio player doesn't use the play method the way the existing audio player uses. This is where we need to implement an adapter that will convert the play MP4 method to the play method of the audio player, which is our existing audio player. To achieve that, we're going to implement a media player class, which is a target. It serves as an interface that any external audio player or engine can use to convert how it plays to the way the original audio player plays. Now that we have the target, we're going to implement the target to adapt this advanced audio player to be able to play with the audio player that we have. So we're going to implement a class called MP4 adapter, which inherits the media player, and on instantiation, we'll take in the media player, in this instance, the advanced audio player. And because it is a media player type, it's going to also implement the play method of the media player. And this play method is what will adapt the advanced media player to use a play method like the audio player, which is the existing player that we want to adapt to. We'll check if the audio type that we're putting in is MP4. And if that is, we're going to call the audio player, in this case, the advanced audio player. We're going to call its method that helps to play music. This method is called play MP4. So right here, you can see we called the advanced audio player, that is audio player, and then we call the MP4 method. And this does the conversion, the adapting of the advanced audio player to the way the audio player plays. If it is not an MP4, then it should throw an error, a value error that it is not a supported file type. Let's take a look at this on the client code. To run a normal audio player, we just instantiate the audio player and we call the play method. We're running a MP3 music and then a wave music. And if we run this code, you're going to see it's going to show us that it's playing give me the song for MP3 and then looking bright as a wave file. If we try to play another music, let's say we try to play looking bright as MP4. If we run it, let me comment these two out, which has already played. If we run it this time, it's going to throw an error saying unsupported audio file because that audio file MP4 doesn't exist on the audio player engine. So to get that to happen, what we're going to do is to use an adapter, and the adapter takes in the advanced audio player that we just instantiated. Now we call the play method of the adapter to play the music. Now we're putting in an MP4 music and we're going to play that music, save the date. Now, if you run that, you'll see that it's now playing save the date as MP4. So we can now play the first two audio with the audio player, and then we can play the last MP4 using the adapter to adapt the music so that the play method can be called to play the music. So if we run this now, you will see it plays the three audio files using their different audio types. We have MP3, wave, and MP4. With the adapter, we were able to convert an unsupported format to become supported. This video is part of a 20 hours Udemy course where we cover hundreds of real-world design pattern scenarios. The course is called Design Pattern in Python with real-world code examples. We showed via practical coding how design pattern is implemented in real-world scenarios like event manager, cache, database connection codes, document management code, creating optimized configuration settings, login frameworks, GUI framework codes, plugin systems, game development codes, payment gateway, document generators, computer graphics generation codes, financial model code pattern, resource pooling, object pooling in ORMs, website creation, database query codes, language translator, web application framework creation, banking system codes, organizational chart creation, file system, interpreter, menu system, text formatting code, authentication code, authorization code, API for OS, document management system, create proxies, event handling, middleware in web development, workflow system, undo redo functionality in apps, job scheduler scenarios, parsers, chart applications, drawing applications, notification system, distributed system, booking system, workflow management system, sorting algorithm, file compression utility, and many more. If you are really serious about your career in programming, you have to get this video, and you don't have to be a Python programmer to use it. Use the link in the description to get the best price for this course on the Udemy platform. Hello, and welcome to this session on Bridge Design Pattern. What is Bridge Design Pattern? The Bridge Pattern is a design pattern used in object-oriented software development that aims to decouple an abstraction from its implementation, allowing both to vary independently. It involves creating two separate hierarchies of classes, one for the abstraction and one for the implementation, and then connecting them through a bridge object. The main objective behind the bridge pattern is to separate an abstraction, such as an interface, abstract class, or API, from its implementation, the actual code that provides the behavior. By doing so, changes to either the abstraction or the implementation will not affect the other, making the system more flexible and easier to maintain. The bridge pattern typically involves creating an abstraction class or interface that defines the method and properties that client will use, and then implementing that abstraction in concrete subclasses or classes that provides the specific behavior. The abstraction class will then use an instance of the implementation class through a bridge object to perform the desired behavior. Hello and welcome back. Let's refactor a car class that has an engine using the bridge design pattern. In this code, we have a vehicle class that has a start engine and a stop engine method. And this vehicle class has two subclasses that create a car and a motorcycle. And then it has, for the car, it also did an extra method called drive. And then for the motorcycle, it has an extra method called ride. So if you want to call a car, you want to start a car, I'm just going to uncomment this. And you can see I started a car, BMW car, started the engine, drove the car using the drive method, and then stopped the car. I also did same with the motorcycle. And you can see started and had the Davidson motorcycle, started the engine, rode the car, and then also stopped the engine. The problem with this design is that the vehicle class is tightly coupled to the specific behavior of the car and motorcycle classes. To adhere to the single responsibility principle of the solid principle, we're going to remove the implementation from the abstract class, which is the car. To do that, the first thing we're going to do is create a vehicle that is, and the vehicle takes in an engine. Like we rightly said, we want to create vehicle and then engine. The vehicle is going to be at the abstraction, and then the engine is going to be the implementation. I'm going to create the other methods for vehicle, but I just want to create the engine, the implementation, so that you could see it separately. This is the implementation, that is the attributes or the behavior of the vehicle. And this is the abstraction class. So the abstraction class is the vehicle. The implementation, that is the engine, has a start and stop method. And from the vehicle, when I create any vehicle, I should be able to start and stop that vehicle from the vehicle type. So that means I'm going to create a start and stop method, which becomes the bridge between the vehicle and the engine. So I'm going to say, do a start engine method. I'm going to start the engine. You see, I already entered the engine when creating the vehicle. Start the engine and implement the start method that the engine gives me. And I'm going to do the same thing for stopping. So I'm going to change this to stop. So when I call the vehicles start and stop, it's going to call the engine start method and the stop method. So this method becomes the bridge between the two abstraction and implementation. Now let's create vehicle types. And I'm going to just implement an extra method that I call drive. So right now, because I inherited the vehicle, it also inherits all this method that are created underneath. So I'm going to do for motorcycle and then also create an extra method that I'll call ride, that rides the motorcycle. Now this is the abstraction. And now for the engine implementation, I can also have different type of engine. I can have a car engine, which implements the start method and also the stop method of its superclass. Let me do another subclass for motorcycle engine, and I'm going to implement the start and stop method for motorcycle engine as it's implemented here in the engine. So the implementation are the behaviors that we're breaking apart from the code from the vehicle. Let's implement another type of engine also. We have a motorcycle and car engine, and let's have a truck engine. This truck engine also has the stop and start. So we can create different engines and then merge it with different vehicle types. So right now we have a different abstraction, that is different type of vehicles. And then we also have different type of engine. So let's do a car engine, which is car engine. Let's instantiate the car engine and then call the car engine inside a car. A car takes in an engine, and that is a car engine. Let's start the engine. Start engine. It's a car, so we can drive it. The car is driven. You can see it's the output showing here. It's a car. We can stop the engine also. Car engine is stopped. And the beauty is that we can also create the second car with a truck engine. And then we can start the engine. You see, okay, let me comment this out. Car 2. You see, truck engine is being started even though it's a car. And then we can also drive it. And then we can stop the engine. This we can also do with the motorcycle. I'm going to comment all these out so we can see the motorcycle example. It's just the same thing, but this time we're implementing the abstraction, the motorcycle abstraction, and putting in a motorcycle engine in it. We started the engine, we rode the engine, we rode the car, the motorcycle, and then of course we can also stop the engine. So you can see we were able to separate the abstraction, the vehicles from their engines, and then we're able to bridge them together using the abstraction methods here. They all work seamlessly together. So we can create more cars and we can create different engines, and then we can also bridge them together to work together the way we want.
Hi, welcome to this session on Composite Design Pattern. Composite Design Pattern is a structural design pattern that allows clients to create individual objects and groups of objects uniformly. It is used when we want to present an hierarchical tree-like structure of objects, and we need to perform operations on them as a single object or group of objects. In this pattern, we have a component interface that defines the common method that can be performed on both individual objects and groups of objects. The component interface can be implemented by a leaf node that represents an individual object or a composite node that represents a group of objects. The composite node can have one or more child components of the same interface. It can delegate the same call to its child components, and it can also perform additional operation on them. This allows us to perform operations on the entire tree structure as a single object or on specific components. Overall, the design pattern helps to create a hierarchical object structure that can be treated as a single object or a group of objects, providing flexibility and scalability to the design.
Hello and welcome back. In this example, we want to create an hierarchical menu structure that has menu and menu items. As is shown in this text, we have menu being the composite, and it has children menu items and also other menus added to it. We'll start by creating a menu item class that takes in a name on instantiation and also defines an ls method that prints out the name. This menu item is a component and it is a leaf item. And then we're going to have composite called menu class, which takes in the name on instantiation, and also have children, that is a list of menu items, or menu as the case may be. The class menu is a composite and it will implement two methods to add items to the self.items list and also to remove from it. To add, we're going to have add item that implements the append method to add items, and remove item method that also uses the remove method of list to remove an item from the list of items. Now we implement a method that performs a similar operations for all the components. And in this case, we're going to call that ls2. And the ls method will print out the name of the composite and also loop through all the items that are in the items attribute, and then calls its ls method also. In the usage code, we're going to start by instantiating different menu items and also instantiating two menus, which are the composites. Then we add an item to the first menu. In this instance, we add a menu item, and then again we add another item to menu 1, but in this instance we add menu class, which is a composite. And then for menu 2, we're going to add item 2 and item 3. To see the structure of the menu, we're going to now call the ls method of menu item 1, and that will list for us all the content in the menu. Menu 1 has an item 1, menu 2, and menu 2 has item 2 and item 3. With this, we can develop multiple hierarchical menu system that performs the same operation like click, over, mouse in or mouse out in this instance.
Hello and welcome back. In this section, we're going to be talking about the Decorator Design Pattern. The Decorator Design Pattern is a design pattern that allows behavior to be added to an individual object dynamically without affecting the behavior of other objects from the same class. It provides a flexible alternative to subclassing for extending functionality. In this pattern, a decorator is an object that wraps around an existing object and provides additional functionality while still maintaining the interface of the original object. The decorator acts as a transparent layer that intercepts method calls, modifies the method behaviors as required, and then passes the call to the wrapped object. This pattern is useful when you want to add functionality to an object at runtime without modifying its source code. It also allows for the creation of complex objects by combining multiple decorators that adds different functionalities to the object.
Welcome back. Let's take a coding example of the decorator pattern by decorating a coffee class. As we have earlier stated, the first action is to create the component. In this case, a coffee class, and then decorate it with as many decorators as we want. To ensure the component and decorator structure doesn't change, we create interface classes to enforce the implementation of the decorator's operations. Now let's look at the code. The first thing I will do is to import an abstract base class. Then I'll create a coffee interface that implement two methods, and those will be abstract methods. The first one will be get costs, which will get the cost of the coffee, and the next will be get description, which will give us the description of the coffee, and it's also going to be an abstract method. Let's use this interface to create a plain coffee. This is the component plain coffee, and that will take in a coffee interface. And of course, with that, I'm going to have to implement the get costs and also the get description. So to get the costs for the coffee, I'm just going to return a cost, say $2, and then the description, I'm going to return plain coffee. Okay, so now I'm going to create a class for the coffee decorator. Now this will be the interface for the coffee decorator, and that will take in the coffee interface. And this time I'm going to create its dunder init method, and the dunder init will take in a coffee. We can also implement the get costs method, which returns the coffee, and the get cost method of the coffee, that is whatever coffee component that is added here. We'll have also do the description, the get description, and then return the coffee get description method. Now that we have the decorator, we can now decide to decorate the plain coffee that we made. Say we want to decorate it with a milk, with a milk class. That will be a decorator, a coffee decorator. It's going to implement the get costs method. And of course, because it's a coffee decorator, it takes in a coffee already. So now that I have a coffee, I'm just going to say self.coffee, just the same way I have this done here. But now because it's a milk, a decorator, I can now, just modify the decorator. Let's add, say milk is $1.99. So basically the get cost is to add to whatever the coffee is, to add a new amount of the new decorator. I'm going to implement the second operation, which is get description. And for get description, I'm going to return self.coffee.getDescription, and then I'm going to add a new description. This time it's going to be milk. I'm going to say dash milk. So this is the new description. So let's do the same thing, add another decorator, and also implement the get cost for that decorator. This is repeating basically what I did here. So I'll say get coffee. What I did here is just being repeated here, but now this is for the sugar decorator. So the sugar, I will make it like $2 also. And I'll do the same thing for description. And then I will return the description, whatever description already exists. And then I will add sugar. So now let's see what output comes out. So I'm going to say coffee will be plain coffee. So plain coffee is a component. Now I'm going to decorate it. But before I decorate it, let me just print out the output of plain coffee. That will be coffee dot get description. I want to get the description, and I want to get the coffee costs. Yeah, it's showing an error, the get costs. This looks fine. So let me see. It has to be how I declared the get cost in the plain coffee. Oh yeah, it's because I didn't put the self word here. So you can see now we have for, let me put mix here. We have plain coffee, and for the price, let me say total. We have $2. Let me just break it into two lines. So we have for the mix here, we have plain coffee and just $2 for that. Now I can decorate that. I can say, I'm still going to call it coffee, decorate it with milk. So it's going to add the description. So the milk takes in a coffee. And as you can see, it's saying the mix is now plain coffee and milk added together. And it's now $3.99. And of course, I can also do the same thing for sugar. And yeah, it's also bringing out some error here. And I guess that's in the description. This line, I should put coffee before get description. So now I have this component and then the two decorators added. So you see, look at the mix. Now we have coffee, milk, and sugar. And now it put together the total amount for these components. They all added together. The decorator pattern is an object that wraps around an existing object and provides additional functionality while still maintaining the interface of the original object. The decorator acts as a transparent layer that intercepts method calls. This pattern is useful when we want to add functionality to an object at runtime without modifying its source code. It also allows for creation of a complex object by combining multiple decorators that add different functionalities to the object. Hello and welcome to this session on Facade Design Pattern. What is Facade Design Pattern? This design pattern is a structural design pattern in software engineering that provides a simplified interface to a complex subsystems of code, making it easier to use and understand. The pattern involves creating a single class called the facade that represents an entire subsystem or a set of related objects and provides a simplified interface to access the functionalities of the subsystem. The facade pattern acts as an intermediary between the client and the subsystem, shielding the client from the complexity of the subsystem and providing a unified interface for the client to access the subsystem functionalities. By using the facade pattern, clients can focus on using the simplified interface provided by the facade object instead of dealing with the complexities of the underlying subsystem. In essence, the facade pattern helps to simplify the complexity of a large system by providing a simple and easy to use interface that abstracts away the underlying complexity, making it easy to use and maintain the system. This video is part of a 20 hours Udemy course where we cover hundreds of real-world design pattern scenarios. Hello and welcome back. In this example, we will look at how we can connect different computer subsystems together to make one single computer system. We will be bringing together CPU subsystem, a memory subsystem, and any other subsystem you might want to add into a facade called a computer system. Every subsystem that makes up a computer are integrated together using a facade to make the system called computer. I'm going to start this code by implementing the first subsystem, which is a CPU subsystem that has a freeze method, a jump method that jump to a particular position, and then execute whatever program it wants to execute. Then we have also a memory subsystem, which holds a dictionary of data and uses the load method to load in a data into the memory, and also the get method to get a data out of the memory. We then integrate all this into a computer system, and the computer system is going to take in all our subsystems. In this case, we have just two, and that is CPU and memory system. And then we'll implement two operations that the computer will do. These are implemented in the run method and the retrieve method as shown. And all operations of the CPU and memory subsystems are mixed together to create a run and a retrieve operation in the computer. For the run method, we do some CPU method, and then we also do some memory method. We load instruction into a particular position, and then we do more CPU method by jumping to that position and executing the code, and then we move our position to another location in the memory. So you can see we have a mix of the subsystem being used in the single run method. And we can do the same thing for the retrieve method. But for this, I'm just going to return the memory location, and other operations can be run using the retrieve method. Now let's run our computer system. We're going to instantiate the computer class, and then we're also going to have a set of instructions that we will want to run, and we will call that program list, and then we'll call the run method of the computer to run each item in the program. And as you can remember, the run method runs through each item in the program and does some calculations or computation with them. Let's look at this in our output. From the output, you can see it takes each item in the lists as a set here. These are the programs, and it runs it through the run method, which does a sequence of activity. We can also use the retrieve method to get a particular program in the memory. And I'm going to print out the retrieve method, which print out the second item in the program list that we have. With the facade design pattern, we're able to use different subsystems to make a computer and to use very simple method or operations on the computer to work with the different subsystems to produce our desired outputs. Hello and welcome to this session on Flyweight Design Pattern. The Flyweight Design Pattern is a software design pattern that aims to minimize the memory usage of an application by sharing as much data as possible within similar objects. This pattern is particularly useful when an application has a large number of similar objects that can be represented more efficiently by sharing certain parts of their states. The basic idea of the flyweight pattern is to create a set of flyweight objects called flyweights that store shared data and can be reused by multiple objects. These flyweights are typically immutable and have a unique identity that can be used to look them up in shared pool. When a new object is created, it is given a reference to the appropriate flyweight object, which it can use to access the shared data. By using flyweights, an application can reduce the memory usage and improve performance, and it avoids creating redundant objects and sharing the data. This pattern is commonly used in graphical applications where a large number of objects with similar characteristics are displayed on the screen. Hello and welcome back. Let's take a look at using flyweight design pattern to create a real-world code for making cars. Let's take a look at the code. I'm going to create a car class, and the car class is going to initialize the make, the model, the color, and I'm also going to initialize where it is shipped to. I'm not going to put anything. At the point of creation, we will not know exactly where it is shipped to. So then I'm going to have another method that states the car information. I'm just going to print out the make, the model, and also I'm going to print out the color. I'm printing out the color and where it is shipped to. Now to do the creation, I'm going to create a car factory, and the car factory is going to have a dictionary where all created cars are stored. I'm going to create a static method called create car, and this is where the cars are created. Every car that is created will be stored here, but this method does the creation and it checks if a car has already been created. And if the car is already created, it's going to check it using the make, model, and the color. If it's already created, it returns that created object. So let's do that here. I'm going to say if the make, model, and color is not in the car factory dictionary, then it should create the car. This is what it's going to do. It's going to create the car the moment it knows it's not there. After creating the car, it should store that value, and then it should store the car in the car dictionary using the make, model, and color as the key. If it already exists, then it should just return the existing car. Now let's run it in the client. We have a main method where we create different cars. We have 1, 2, 3, 4, 5 cars we are creating here. You remember that we didn't specify the ship to value to know exactly where the cars are shipped to. So what I'm going to do here is to create a list of locations where they will be shipped to. And then I'm going to loop through each cars, these cars. And then for each car, I'm going to call the shipped to, and I'm going to randomly choose a location. So I'm going to import the random module, which helps me randomly choose from this list. So I'll say random, use the choice method to randomly pick from any of these locations and put it into the shipped to. So, and I haven't done that. I'm going to call the car info method, and you can see right here. Let me change this to get info. It makes more sense. So, the car get info method will get the info for every car, and it will return it and put. You can see for this first car, we have a red Toyota Venza. The fourth car also is a red Toyota Venza, but you can see the locations are different. So what the flyweight helps us to do is those objects that are similar can be shared. The first one was created, but when it got here, it did not create it. It used the object that created the first one, but it has some unique states for each of the objects. And the unique state in this instance is the USA and the China. So here, the shipped to was just created when each of the objects was created. Now let's check and be sure. Okay, I want to, make us see the cars. I will just say enumerate cars one. That means count the cars one after the other and use the enumerate function. And I'm just going to print out car and number. So you can see it prints the first, second, third, fourth, and the fifth car. To see the total cars that were made, I'm just calling the length of the cars that were made here. You can see it's showing me that total cars are 5. And let's see the total objects that was made. During the creation process, I'm going to instantiate a variable here. I'm going to make it 0. That is, every time there is a creation, it should increment this value, that is the created value. And at this point, we created the car, and I'm going to increment the created value here so that it will be 1. Every time there is a car that is created, the underscore created variable is increased. So right here, I'm just going to print out the total objects that were created. So if I print out the total objects, you will see in the result is saying 3 objects were created. Even though we have 5 objects, 1, 2, 3, 4, 5, but it recognizes that Toyota Venza Red are the same. So it did not create that again. It also recognized that Toyota Corolla Blue and this Toyota Corolla Blue is the same thing with this. So it did not create this. So it created one of these, created one of these, and created another one, Camry Hash. And that is why you see the total cars are 5. The total cars that were created are 5, but actually the total objects that were made are 3. So in the memory, 3 objects were created, but the total cars that were created are 5. If I increase the cars, I create another car here. Now I have 3 blue cars, 3 blue Corollas. This one. You will see the total cars are actually 6. If you count them, they are 6, but it did not increase the number of objects that was created in the computer. And you would notice car 2, car 5, and 6 are the same cars, but because they have unique states, car 5 was sent to Germany, car 6 was sent to China, and car 2 was sent to Nigeria. The Flyweight design pattern helps to minimize the use of memory for objects that are similar. Hello and welcome to this section of design pattern. We'll be talking about Proxy design pattern. This video is part of a 20 hours Udemy course where we cover hundreds of real-world design pattern scenarios. The Proxy design pattern is a behavioral pattern that allows a client to interact with an object indirectly through a proxy object. The proxy objects act as an intermediary between the client and the real object, providing additional functionality such as caching, security, or remote access. In the proxy design pattern, the proxy object has the same interface as the real object, so the client can use it interchangeably with the real object. The client is unaware that it is using a proxy object, as the proxy object transparently forwards requests to the real object and may also perform additional tasks before or after forwarding the request. The proxy design pattern can be used in situations where the real object is resource intensive to create, or where access to the real object needs to be controlled or secured. It can also be used to add additional functionality to an object, such as logging without modifying the original object code. Hello and welcome back. Again, let's take another example code of proxy design pattern using a virtual proxy as an example. What is a visual proxy? Visual proxies are used to create objects that are expensive to create. The virtual proxy creates a lightweight placeholder object and defers the creation of the actual object until it is needed. Let's take a look at an example code. In this example, we'll declare an abstract image class that implements an abstract display method. Now I have the interface, and then I can create a real image that takes in the image class, and it also takes in a file name, and then use the file name to load an image from disk. Now I'm going to have the load from disk method, and that just takes in a print of the file name that has been loaded from disk. On instantiation, the image is loaded from disk, and then display method displays the name of the image that was loaded from disk. This is a good example of where we need the proxy. So the proxy will delay the loading of the image until it is needed, so that instead of calling the real image class, we call a proxy image class, and the proxy image class takes in the file name, and it also takes in the image, but on instantiation is not going to put in anything. So instead of automatically loading the image from disk, we're going to be using the proxy to load it, but on instantiation is not going to load any image. The loading will be done in the display method, that is where the image is needed. So we check if the real image is not loaded, then it should load the real image from disk, and then we'll pass in the file name. On calling the proxy, it's not going to do the loading until the display is called. So it does a lazy loading of the image. That is what virtual proxy does. After loading the image, then it can call the real image display method. Okay, so let's run this code. Let's do the client code. So we use the proxy image to load the first image, image 1, and then we also load another image. I'll call that image 2. On instantiation, using the proxy image, the two images are not loaded. They are only loaded when you call the display method. And you can see right here, when I call the display method, it actually does the loading of the image and then displays the image. And because it has already been loaded, if I do it again, it doesn't say load image again. It just goes to display image because that image has already been loaded. And even at that, image 2 is not loaded. Image 2 is only loaded when I run its display method. And you can see right here, image 2 is being loaded, and then it has displaying image 2. So if I do another load of image 2, it's not going to load another one. It's just going to show you displaying the image because the image has been loaded into the memory. If I do another one, it's not going to load another image. It's just going to show you that the image is being displayed because it's already in the memory. So the virtual proxy helps to do lazy loading, and it allows you to save memory usage until it is needed. This video is part of a 20 hours Udemy course where we cover hundreds of real-world design pattern scenarios. The course is called Design Pattern in Python with real-world code examples. We showed via practical coding how design pattern is implemented in real-world scenarios like event manager, cache, database connection codes, document management code, creating optimized configuration settings, login frameworks, GUI framework codes, plugin systems, game development codes, payment gateway, document generators, computer graphics generation codes, financial model code pattern, resource pooling, object pooling in ORMs, website creation, database query codes, language translator, web application framework creation, banking system codes, organizational chart creation, file system, interpreter, menu system, text formatting code, authentication code, authorization code, API for OS, document management system, create proxies, event handling, middleware in web development, workflow system, undo redo functionality in apps, job scheduler scenarios, parsers, chart applications, drawing applications, notification system, distributed system, booking system, workflow management system, sorting algorithm, file compression utility, and many more. If you are really serious about your career in programming, you have to get this video. And you don't have to be a Python programmer to use it. Use the link in the description to get the best price for this course on the Udemy platform. Hello, and welcome to this session on Chain of Responsibility Design Pattern. The chain of responsibility is a behavioral design pattern that provides a way to pass a request along a chain of potential handlers until one of them handles the request. The pattern decouples senders and receivers of a request, allowing multiple objects to have a chance to handle the request without explicitly knowing which object will handle it. When a client sends a request, it is received by the first handler in the chain. This handler examines the request and decides whether it can handle it or not. If it can, it processes the request and completes the handling. If not, it passes the request to the next handler in the chain. This process continues until a handler handles the request or until the end of the chain is reached. The chain of responsibility pattern promotes loose coupling between senders and receivers, as neither needs to have direct knowledge of each other. It allows for flexible and dynamic handling of requests, as the chain can be modified or extended at runtime. Hello and welcome back. Let's take an example code of a simple implementation of chain of responsibility design pattern. And in this code, we're going to be starting with an abstract base class, and the abstract base class is going to have a contract, that is the abstract implementation or interface, that on initialization takes in a successor, and that successor actually is a handler. It's a handler that is optional. I'm not going to be using type inting here, so I'll just put it this way. And this is a handler, and this handler is initialized at this point. The handler interface also have an abstract method that is the request handler that handles the request that is passed across the handlers. So now I'll create a concrete handler, and the concrete handler implements the handler interface contract that we have here, and also implements the request handler as is defined here. It expects a parameter, so we check if the request, that is the request parameter here, is A. That's what we're checking against. If that's the case, we print out the request is handled at handler A. And if this handler has a successor that is not none, then it should say the handler 1 is not handling this request, because right here, if it is A, if the request is A, it should handle it. If the request is not A, and it should check if there is a successor. If there is a successor, it should pass the request to the successor request handler method. So the request is passed to the successor request handler method. And here we define similar implementation for other concrete handler. This is concrete handler 2. And in concrete handler 2, we also define the request handler. And in concrete handler 2, we're checking if the request, the parameter entered is B. If it is B, then it should say the request is handled at B. And if it is not, then it should say handler 2 is not handling this request, and it should pass the request to the next handler. That is, if handler 2 has a request handler attached to it. So I'm going to do for the third one now, and basically I'm just going to change this to 3, change this to C, and change this to 3. That is, again, this is the third request handler, and it checks it handles the request if the request entered is C. If it is, it will say request is handled at handler 3. And if it has a successor, it should pass the handling to the next handler. This time, I'm just going to end it here as the last handler. And I'm going to move this right here. That is, if it has a successor, then it should handle. But because this is the last one, it doesn't have a successor. So it's just going to come here and run. Handler 3 is not handling this request. And I'm also going to put up an output saying request handling is terminated because this is the last request handler. Now let's do the client. And in here, I'm going to instantiate handlers, handler 1, 2, and 3. And then I'm going to say handler 1's successor is handler 2 and handler 2 successor is handler 3. So right now I've specified the successor for the 2. And now I can work on handler 1 and run the request handler and pass in a request, say C or B. When we run the code, you will see that because we passed in B, it tried to run it with handler 1, and handler 1, it says handler 1 is not handling this request, and then it says B is handled at handler 2. Basically what it did was that it tried to handle the request here. It says is request A is not A, so it passed that request to the next handler, and the next handler, the successor handler for handler 1 is handler 2, so it passed it to handler 2, and then handler 2 checked and saw that is B and then handled the request. If we put it to C now, you will see handler 1 is not handling the request. It tried handler 1 and then it passed it to its successor, which is handler 2. Handler 2 is not handling the request, and then it passed it to handler 3, which is C. It is handler 3 that handled the request. And of course, if you have A there, A will handle the request immediately. But if you have something like F, which is not existing, it's going to show you that handler 1 didn't handle it, 2 didn't handle it, 3 didn't handle it, and then it terminated. Request handling was terminated because there was no handling. So what we've been able to achieve is that we have several handlers walking through the request to see if they can handle it, and when they can handle it, that handler handles it. And we can run this code this way, or we can actually loop the handlers. Let me comment this out and then create another handler 1. That is, you can say concrete handler 1, and it takes a successor, which is also a handler. You can pass that in here as the second handler, and then it takes the second handler also takes in handler 3 as a successor, and you can see the code continues to run the way it is. If I put B here, it's going to show that handler 1 didn't handle it, is the second handler that handled it. So either you run it this way, you loop in all the handlers in there, or you can just specify it this way depending on how you want to do it on runtime. Hello, and welcome to this session on Command Design Pattern. The Command Design Pattern is a behavioral design pattern that provides a way to encapsulate a request as an object, thereby allowing users to parameterize clients with different requests, queue or log requests, and support undoable operations. It decouples the sender of a request from the object that performs the action, providing flexibility and extensibility in designing and managing requests. The main idea behind the command pattern is to represent a request as an object, which allows for greater flexibility and extensibility in handling actions and interaction in a system. It promotes loose coupling between the sender and receiver of a request by eliminating direct dependencies and allowing them to vary independently. The command pattern allows the coupling of objects involved in a request, making the system more flexible and scalable. It enables the construction of complex systems based on small reusable command objects and supports operations such as undo and redo by keeping an history of executed commands. Additionally, the pattern facilitates the implementation of features like logging, queuing, and scheduling of commands. Hello and welcome back. Let's take a real-world code example of command design pattern, and we'll be implementing a remote control application in this example. We will start with the receiver, which is a TV class that has a turn on method and also a turn off method. And now let's have the command that implements the TV receiver, the TV, and we'll start with the interface implementation, and that will be class command. And the class command will have an init method that takes in a TV, and then it's also going to have the execute method that runs the TV operation. And here I'm going to make it an abstract class, which is the right way to go. So I'm going to turn this to ABC and make an abstract method also. Let me also demarcate the code. I have the receivers here, and then I'm going to have all the command here. The first command I'm going to have is the turn on command that implements the interface command and its method execute. And the execute will run the TV turn on method. When we execute a command, it's going to be executing the turn on method of the receiver. And we'll do the same thing also for a turn off class, which is a subclass of the command interface, and then also run the execute method, which calls the turn off method of the TV. Now we're going to have the invoker. The invoker is going to be a remote control class, which initializes a command attribute, and then the command is set using the set command method. So here we'll set the command. So basically the remote control takes in a command. If you press any of these command, the set command will set that command on the remote control. And the last method I'm going to have here is the press button method. And the method will check if there is a command that is already existing, that is, a command is set. And if a command is set, then it's going to execute that command. So let's run the client now. I'm going to put a divider there, and then the client code. The first thing is we're going to instantiate the TV, and then I'm going to instantiate the turn on command and pass in the TV that I just created. And I'm going to do the same thing for the turn off command. I'm instantiating the TV, and now I'm creating the command turn on and turn off command. And after that, I will instantiate the remote control, and I'm going to set the remote control using the set command to set the command that I just created. So I have set command, and I'm putting in the turn on command and press the remote button here so that I can see what happens. Now let's run through the code one more time. I have a receiver. The receiver is the implementation, the TV itself. And then I pass that TV into a command. I create different commands. The first command I'm creating is turn on command. And then the second command I'm creating is to turn off the TV command. And after creating that, I create the remote control, which is the invoker. And the invoker has a set command to set each of the command, and then a press command to execute whatever the command does. So here I created the TV, and then I instantiated also the two commands and passed in a TV, and then created a remote control, and then use the set command to set the command onto the remote control. That is more like pressing the command on the remote control. Then I implement the press button for it to execute the command that I passed in. Now let's look at what happens here, because I'm executing the command from the remote control. You can see it says TV is turned on. If I change this, maybe on the next line, I turn it to the turn off command and I execute it again, it's going to say TV is turned on. So every time I set the command and I press the button, it's going to either turn on the TV or turn off the TV. Again, note the functionalities that you have to implement. First is the receiver, which is the real code. Then the command, which issues the command for the code, the implementation. And then the remote control, which is the invoker, which invokes whatever command you have issued. So, and then of course, the client code that shows you the command and the invoker, which is the remote control in this case. Hello, and welcome back to this session on the Interpreter Design Pattern. The Interpreter Design Pattern is a behavioral design pattern that defines a language or grammar and provides a way to interpret and execute sentences or expressions of that language. It is used to solve problems related to language processing, rule-based system, or domain-specific languages. The Interpreter Design Pattern allows you to define a grammar for a language and provides a way to interpret and evaluate the expression in that language. It is often used in scenarios where you need to process or evaluate textual expressions, query languages, or configuration languages. The pattern involves representing each grammar rules as an object or class, with each rule typically corresponding to a specific operation or behavior. The grammar rules are combined to form complex expressions or sentences, which can then be interpreted and executed. Hello and welcome back. Let us take another code example of a shopping cart context using the Interpreter Design Pattern. We will be implementing a simple language for calculating the total cost of a shopping cart based on the quantity and price of item. The shopping cart will be the context in this example. The shopping cart holds any necessary data or variable that are required during the interpretation process. You can see right here, the shopping cart has a dictionary of items. I'm going to call this shopping cart alone. It's actually the context. And then the shopping cart context takes in add item to add a new item into the dictionary that stores the current state of the data. And then I'm also going to have another method that is called get item. The add item takes in the name of the item and then the quantity of the item, while the get item just returns the quantity of the item that is added. So the context in this instance represent the current state or context in which the expressions are being evaluated. In other words, it holds any necessary data or variable that are required during the interpretation process. Then we have the abstract class or interface that all expressions will implement. And then I'm going to start with a terminal expression, and that will be called item price. And then I'll have a non-terminal expression, which is addition and subtraction. So I'm going to implement the terminal expression, the item price, which takes in the name and the price of the item in the cart. So it is initialized here, name and price. And of course, because inheriting the expression, I'm going to be implementing the interpreter. The essence of the item price terminal expression is to return the total price of the item in the cart. So what I'm going to do is, first of all, to get the quantity of item, I have in the interpret method, the context, which is this, I'm putting in the context, that is the data, and I can then get the context item method, and that will return the number of items in the cart. So having done that, I'm just going to return the price of the cart multiplied by the quantity. This item price return the total amount of the specific item in the cart. So we'll give it the name of the item, which is stored in the context, and then we'll multiply it by the price. Now that we have the terminal expression, we're going to instantiate the addition. We want to add all the items in the cart. I'm going to have the expressions. The expression will take either the terminal expression or the non-terminal expression. For addition, we're going to implement the interpret method, and the interpret method returns the expression interpret method, and then adds also the second expression interpret method, which takes in a context. If we want to get the subtraction non-terminal expression, we basically do the same thing. We just copy this. That is, we initialize two expressions that we want to subtract, and then this returns whatever value comes out of any of these operations. It then implements subtraction on it. Let's implement the client, and we're going to create the shopping cart basically because we want to create the data that we'll be working with. And what we'll do is that we'll add 3 data essentially. So we have 3 items in the shopping cart: 2 mangoes, 7 paper roll, and then 3 deodorants are added to the cart. Now let's create the expression, and in this expression we're gonna do an addition of 2 of the expression. The first expression will be the item price, and of course this item price will calculate 3 deodorants at $15 each. And because this takes in just 2 parameters, this is the first parameter, which is an expression. The second parameter is an expression. So we're going to put in another add, and in that add, we're going to put in 2 more expressions. So right here, I have 3 items that I am adding together. So having done that, we can now just calculate the total expression. This expression, we're going to interpret the expression so that the calculation can be done into the variable total cost. And we can just print that out to see what the value will be. I'm running the code now, and it's giving me some error on line 23. Let me look at line 23. It said get underscore item. It has no attribute like that. Yeah, it's supposed to be get underscore item. I'm going to take out 1 underscore. Yeah, and then you can see the total price is adding together. All this price is being added together to give you $76. And if you do the math, you would see we have 3 deodorants multiplied by $15 each will give you $45. We have 7 paper roll multiplied by $3 each, and that will give you $21. We have 2 mangoes multiplied by $5 each, which is $10. If you put it together, 45 and 21, 66, and this, and that is $76. So it adds it all together using the interpreter design pattern. So $76 is a combination of these 3, $45, the 21, and $10 added together. It doesn't have to be addition. We can change it to subtraction. So let's say we change this to subtraction. You see, it changes to $14, because what that does is that it takes the first one and then subtract it from the addition of the second and the third. So it subtracts this expression from this expression. And if you calculate it, it's going to give you $14 altogether. The interpreter method allows us to use this expression to do whatever calculation we intend to do. The interpreter design pattern creates a language, and this language or grammar provides a way to interpret and execute sentences or expression of that language. Hello, and welcome back to this session on the Iterator design pattern. What is the Iterator design pattern? The Iterator design pattern is a behavioral design pattern that provides a way to access the elements of an aggregate object, such as a list, array, or collection sequentially without exposing its underlying representation. It allows transversal of the elements of a container object in a consistent and efficient manner. The key idea behind the Iterator pattern is to separate transversal logic from the container's object itself. This separation improves the flexibility and extensibility of the code by allowing different transversal algorithms to be used with the same container without modifying the container's structure. This pattern is commonly used by many libraries in Python to transverse elements in them. By using the Iterator pattern, client code can iterate over the elements of a container object without being concerned about the underlying structure of implementation details. This promotes loose coupling between the client and the container object, making the code more maintainable and reusable. Hello and welcome back. Let's take a sample code of iterating through dictionary data, and we're going to be continuing from where we left off in the last code. And in the last code, we have my iterator, and the my iterator, we passed in an iterable, and the iterable will loop through the iterable, and it gives us this. Now, as long as they are iterables like a list, st2 tuple, or lst3 string, is going to work. But passing through a dictionary is not going to work because dictionary doesn't take in index. It's a key pair combination. To update this code to be able to take in dictionary, what we're going to do is add the keys. To get all the keys, I'm going to put them in a list, and that will be from the iterable data keys. I'll use the keys method of a dictionary to get all the keys that are associated with the dictionary that we are putting in. I'm going to now get a specific key by saying self.keys. That's all the keys that are in the list. And then I'm going to pass in the current index to get the key. This will retrieve the current key for me. Now, to get the current value, I'm going to change that item to value. I'm going to slot in the key on the iterable. This code will retrieve the key, while this code will retrieve the value. I'm going to return the key and value. Instead of returning only an item, if it is a list or a tuple, because it's a dictionary, it's a key value combination, I'm going to return that pair as what is returned. The keys is a list, so it should be square bracket. Now that I have that done, you can see immediately it returns a tuple. This is a tuple that I'm asking it to return. It returns a tuple of the age and the gender. And of course, if I want to make it maybe a little bit more better, I can just return the key and value separately and then put it in a string, and then it shows the name, age, gender, level in this format. So if you're not using a list, if you're using a dictionary, you're going to have to implement it differently. And basically is getting all the keys in a list, get the key in the first position and pass it into the dictionary to get the keys and the values, and then return that as a tuple. Hello, and welcome to this session on the Mediator design pattern. This video is part of a 20 hours Udemy course where we cover hundreds of real-world design pattern scenarios. The Mediator design pattern is a behavioral design pattern that promotes loose coupling between a set of objects by centralizing their communication through a mediator object. It allows objects to interact with each other indirectly through the mediator, rather than directly communicating with each other. This helps to reduce the dependencies between objects, simplifies their interactions, and enhances their reusability. In the Mediator pattern, the mediator object encapsulates the communication logic and controls the flow of messages between objects. It acts as a centralized hub or facilitator that coordinates the interaction between the participating objects. Instead of objects communicating with each other directly, they send messages to the mediator, which then handles the routing and delivery of those messages to the appropriate objects. By decoupling objects and relying on a mediator, the mediator pattern enables objects to focus on their individual responsibilities without being aware of the details or existence of other objects. This promotes better encapsulation and modular design.
Hello and welcome back. Let's take another real-world code example of an air traffic control system using the Mediator design pattern. And in this example, we'll have an air traffic control mediator class that acts as the central mediator for the air traffic control system. It maintains a list of registered aircraft, and it also provides a method for registering the aircraft. It also has a notify aircraft method that loops through all registered aircraft and allows only aircraft that are not the sender to receive the message. Now let's implement the aircraft, which are the participants in the aircraft traffic control mediator. The aircraft class represents individual aircraft in the system. Each aircraft has a call sign and a reference to the mediator. It also implements two methods, the send message method and the receive message method. The send message method is used to send messages to other aircraft through the mediator, while the receive message is called by the mediator to deliver messages to the aircraft. So the send message method simply sends a message through the mediator, and that calls the notify aircraft method of the mediator class. And also the receive message only prints out the notification that is sent to other aircraft. So an aircraft will send a message, and other aircraft that are in the mediators will receive the message using the receive message method. Let's run the code again. We'll create the air traffic control mediator. We will create first aircraft. The first aircraft will have its call sign and then the mediator that it's using. And let's create two more aircrafts. We have aircraft 2 and aircraft 3. Now let's register the aircraft so that the aircraft are registered in the aircraft list as aircraft that messages need to be sent to. Let's register the other 2 aircraft. So we have 3 aircraft registered here. Now let's attempt to send a message from aircraft 1, and the message says send message traffic adversary descending to 10,000 feet. And this message will be received by the other 2 aircrafts. Let's run the code in our output tab, and you can see here when we send the message through traffic 1 is flight 123, it sends that message to aircraft 456 and 789. Those are the other aircrafts that are in the list. I can also send another message. Let's say we send through aircraft 2, and now the message through aircraft 2 also goes. Okay, let me separate them. Let me put a print method here. Okay, you can see the first message that I sent went to aircraft 456 and 789. And then for the second message, it went to flight 123 and 789. This video is part of a 20 hours Udemy course where we cover hundreds of real-world design pattern scenarios. The course is called Design Pattern in Python with real-world code examples. We showed via practical coding how design pattern is implemented in real-world scenarios like event manager, catch,
database connection codes, document management code, creating optimized configuration settings, login frameworks, GUI framework codes, plugin systems, game development codes, payment gateway, document generators, computer graphics generation codes, financial model code pattern, resource pooling, object pooling in ORMs, website creation, database query codes, language translator, web application framework creation, banking system codes, organizational chart creation, file system, interpreter, menu system, text formatting code, authentication code, authorization code, API for OS, document management system, create proxies, event handling, middleware in web development, workflow system, undo redo functionality in apps, job scheduler scenarios, parsers, chart applications, drawing applications, notification system, distributed system, booking system, workflow management system, sorting algorithm, file compression utility, and many more. If you are really serious about your career in programming, you have to get this video. And you don't have to be a Python programmer to use it. Use the link in the description to get the best price for this course on the Udemy platform. Hello, and welcome to this session on Memento Design Pattern. The Memento Design Pattern is a behavioral design pattern that provides the ability to capture and restore an object's internal state without violating encapsulation. It allows you to save and restore the state of an object, effectively creating a snapshot of its current state. The Memento pattern allows an object to be restored to its previous state, providing undo and redo functionalities. It also enables the object to save its state externally, so it can be persisted or transferred between systems. Overall, the Memento design pattern provides a flexible way to capture and restore an object state, ensuring encapsulation and supporting undo and redo operation and state persistence. Hello and welcome back. Let's take a simple example of Memento design pattern. And in this example, we're going to start with an editor class. The function of this example is an editor class that saves different states of its content using the Memento. Our editor class will instantiate a content attribute on initialization, and then it also has a method add text that adds a textual content to the content attribute. We can also have a get content. So this is the setter for the content, and then this is the getter for the content. Then it also implements the method create Memento. We're going to be creating that class later. It's an object that saves the state, a specific state in our editor. And then we also have the restore Memento that takes in a memento, and then this restores the state that was initially saved. Now let's implement the Memento, and we simply have a class that takes in a content. So right here, whatever content we want to save, when you call Memento, it just saves that content into save content variable. And if we want to get the content, we just use the get saved content method of the Memento to get the content. So we save the content on initializing the Memento, and then we also get the content with the get saved content method. Also, we're going to implement a caretaker class, and the caretaker class takes in every saved memento into a list. So when you save a memento, you add it using the add method of the caretaker into the mementos list. So it contains list of saved mementos, which is an object that represents the saved state of the originator. And the originator in this instance is the editor that does the creating of the mementos. Now let's run this. The first thing I'll do is to create an editor, and I'm going to also create a caretaker. The editor is the originator, and that is, it will create several saved states using the Memento, and the caretaker will store all the saved states of the originators. Let's start by adding a text into the editor using the add text method, and then we can save that state using the add memento method of the caretaker, and the add method of the caretaker will take in the editor create memento, will create a memento that the add mementos method of the caretaker will store. You can see here this appends all the mementos to the mementos list. So let's create some more. I'm going to add world. So in the editor, we have hello world, and I create another state to store the word text into the memento. That is the list we have here. And then I create the last word, which is goodbye. And if I print out this text right now, printing out the content, it shows us hello world, goodbye. We can restore an editor back to its last state by calling the restore memento and restoring the memento from the caretaker. We're going to be calling a get memento method from the caretaker, and we'll restore the last state. That method doesn't exist. I didn't implement it. So basically what that does is just, I'm going to call the get memento, which returns mementos index that is supplied here. What we did here was we did restore memento, and we took that memento from that list, from the mementos list using the get memento, and we took the first index. If we print this code again, you would see that it restored the last state of the editor. The last state that was saved was hello world. And I can also have it do it again. Now restore from the caretaker, the get memento method, restore to the first face. And you would see if I print out the content of the editor, it's going to show the first state, which is hello. And the memento stores each state. Again, let me take it. When we created the editor, which is the originator that create the states, we added text, and every text we added, we use the create memento to add it as a state. So the first text we added was hello, and that text was added to the content, that is the editor content. And when we did another add context world, the content now is not just world. The content now is, it's adding the first hello to world. So the content now is hello world. Whatever thing you add is added to the content, and then you use the memento to store each state. The first state we stored here is hello. The second state we stored here is hello world, because we're taking from the content, and then we had goodbye. We didn't store the state. And if we want to store the state, we can also store the state. For instance, I can come here and say store the state of this memento, create the state, print it out, and then restore the first index, restore the state in the 0 index, and I can go back to, let me copy these and say the second one. I have 3 states in there, and you can see now that I called this, it actually restored it back to the full context there, because each of the state was stored using the memento, and the caretaker has all the states stored in a list. And anytime we call the index of the list, it returns to us the content of that object, the memento, which is the state of the originator that was stored in the memento. It's a simple implementation. You can just go through it again and you can see how it works. Hello, and welcome back to this session on design pattern. We'll be looking at the observer design pattern. The observer design pattern is a behavioral design pattern that establishes a one-to-many dependency between objects. It defines a subscription mechanism where one object, called the object or observable, maintains a list of other objects called observers and notify them automatically of any changes in its states. The main goal of the observer pattern is to ensure that multiple observers can be notified and updated when the state of the object changes, without the object needing to have direct knowledge of the observers. This promotes loose coupling between the subject and the observer, enabling a more flexible and maintainable system. In the observer pattern, the subject maintains a list of observers and provides a method to subscribe and unsubscribe observers. When the subject's state changes, it notifies all the subscribed observers, typically by invoking a method on each observer. The observers can then perform their specific logic based on the updated information received from the subject. This pattern is widely used in event-driven systems, graphical user interface, and many systems where the decoupling of components is desired. It promotes a modular and extensible architecture, as new observers can be easily added or removed without affecting other parts of the system. This video is part of a 20 hours Udemy course where we cover hundreds of real-world design pattern scenarios. Hello and welcome back. In this real-world code example, we're going to see how we can implement event handling using the observer design pattern. We're going to first start by creating an event object, and the event object holds the event type and also the data that the event is pushing. And then we create the subject. I'm going to be calling it either subject or observable or publisher interchangeably because they are the same thing. And this is where the observers are kept. The event handler class manages the observer and handles the notification process. It has two methods for attaching an event type and an observer. And technically what this does is that it checks if the event type exists. If it doesn't, it creates an event type that takes a list of observers. And if the event type already exists, then it just appends observers to that event. And then also after implementing an attach method, it also implements a detach method which remove observers from an existing event type. It also implements the notification method, which is called notify, and that takes in an event object. And as you know, an event object takes in the type and the data. And so it checks the event type from the observer dictionary. It checks if the event type exists amongst all the observer dictionary. And if it does, then it loops through all the observers and runs their update method and then passes the event object to the update method. So every observer will get the event and then process it appropriately. To create the observers, I'm going to create an abstract class called observer. That's the contract that the observer will be implementing. I've already inherited abstract base class. After that, then I can now create the concrete observer. Now I'm going to start with a button clicked observer. And the button click observer, of course, will implement the update method, which is called when a notification is sent. And it takes in the event. As you can see here, every observer runs the update method and takes in an event. And in this instance, the event is taken in. If that event is a button click event, then it's going to be printing out button clicked and the data that is in the event. And then I'm going to create another class, a mouse move observer, that inherits the observer interface, and that also checks if it's a mouse move, and then it prints out mouse move event. Now let's do the usage of this code, the client side. The first thing I'm going to do is to create the observable or subject, and then I'm going to also instantiate the mouse click object and the mouse move object, and also attach it to the subject, the event handler that was created here, and pass in the different observers. And then I'm going to fire this event by notifying of an event. An event is a click event. It's send, submit, button clicked. So the event handler will go through all the events, and then when it finds the event that has a button click, it's going to run that. And this is the class that runs that. Let's look at the code. You can see from the output, it said button clicked, This is the button click event, and then it shows the data that is in the button click. Let's run another event. This time is a mouse move event. This mouse move event just does mouse move and then give out the data. And this is the data that is in the mouse move event. So the notify method of the publisher will publish to all the observers, and the observer that will implement the event will capture that notification and then it will publish it. Let's detach one of the events from the observable dictionary. So we're removing the button click. If we send a message, that button click notification will not be processed by the method because it has been detached from the event handlers. If I comment this out, you will see it's going to show it, but if it is detached, it's not going to run that class. It's not going to go there because it's only going to check with the mouse move observer, and the mouse move observer will not process it because it's a button click event. There are several methods that you can do event handling. You'll remember that in the Mediator pattern, we did the same event handling process, but in a different way. But in this instance, we used the observer pattern to implement event handling, and it handles the event. It depends on what you want to achieve and how you want your event to be handled. That will determine the type of pattern that you will use to implement your code. Hello, and welcome to this session on State Design Pattern. The State Design Pattern is a behavioral design pattern that allows an object to alter its behavior when its internal state changes. It enables an object to appear as if it is changing its class, as the object's behavior is determined by its current state. The state pattern promotes encapsulation and separation of concern by representing different states as separate classes, each implementing a common interface. The main idea behind the state pattern is to encapsulate the behavior associated with each state into separate classes known as state classes. This state classes defines the method and actions that are specific to that particular state. The context class, which represents the object whose behavior is being controlled by the state, contains a reference to the current state object. The state design pattern is useful in scenarios where an object's behavior varies based on its internal state, and when you want to achieve cleaner code organization, improved maintainability, and extensibility. Hello and welcome back. Let's take another real-world code example implementing a light traffic system using the state design pattern. Again, I'm going to put the comment of state and context so you know which classes go for that. And in this example, we're going to implement a traffic light class that represents a traffic light system. The traffic light class maintains a reference to the current state, which initially is set to the red state. The traffic light method implements two methods which displays light and then change light. The display light method will return the current light state that we are on, and then the change light changes to the next state. Now let's implement the light state. And in the light state, we're going to bring in an abstract base class of traffic light state, and the abstract class also implement a display light and change light for every state that it implements. Now we're going to start by implementing the red light. You know, the red light is the initial light state we have. So we're going to implement the red light. And then in the red light, we're going to also implement its display light, because the red light is a concrete class of the traffic light state. For display light, it returns red light. And then we also implement its change light method, and the change light method change to the next state. And the next state we have here is green. And then this is repeated again for the green light. I'm going to put all the codes for the green light here. For the green light, you see it implements the display light, which returns the light, and then the change light will change light to the next state, and the next state is the yellow light. And this is also the same thing in the code. You can see the yellow light displays yellow light, and then when you run the change light for the yellow light, it returns back to the red light. This is basically how the traffic light works. Now, for the display light in the context, in the traffic light class, this runs for each state. Now, if the state is red light, it runs the display light for the red light. And if it is another state it finds itself, it's going to run that state display light. And then, of course, for change light, it runs the state change light method. After instantiating traffic light, every time you call the display light, it displays the current state that it finds itself. It runs the state display light method. And then if you want to change to another light, you have to run the change light method. Let's take an example, and let's start by instantiating the traffic light. And for the first traffic light, I'm going to print out the light that it returns. For the traffic light, run its display light. If we run this code, it returns the red light. And if you again print out another display light, it's going to run red because that's the current state. If you want to change the state to the next stage, then you'll have to use the change light method of the current state. And the change light method of the current state moves you to the next stage. And as you can see here, the first one is red light, and the second one says, let me put a print here. I like always separating the outputs. So you can see the red light was the first initial state, and then it changed state, changing from red to green. If I change the state again and then display it, you would see it's going to change to yellow. If this change state is not there, it's going to remain as green. But with the change state, it changes to yellow. Let me put this here again. So you can see every stage changes as I run this change state and the display light. Now again, it has changed to red. So you can see it changing from red to green to yellow and back to red, just like a normal traffic light will work, because every time we run the display light, it returns the current state. It returns the current state light. And every time we run the change light, it changes the current state to the next state. For red, in this instance, it changes it to the green state. And then if you run the display lights for the green state, it gives you green. This is just another simple implementation of the state design pattern. Hello, and welcome to this session on strategy design pattern. Let's look at what strategy design pattern is. The strategy design pattern is a behavioral design pattern that allows you to define a family of algorithms, encapsulate each one as a separate class, and make them interchangeable. It enables the algorithm to vary independently from the client that use them, allowing runtime selection of the algorithm based on the specific requirements. The main idea behind the strategy pattern is to encapsulate a group of algorithms and provide a common interface for them. This interface defines a set of methods or operations that the algorithm must implement. The client code can then utilize this algorithm by interacting with the common interface without knowing the specific implementation details of each algorithm. By encapsulating the algorithm in separate classes, the strategy pattern promotes code reuse, improves maintainability, and allows for easy extension. It also enables the selection of the algorithm dynamically at runtime, providing flexibility and the ability to switch between different strategies without modifying the client code. Hello and welcome back. Let's take a look at an example code that explains the strategy design pattern. Implementing a strategy requires about 3 main classes, and this includes the strategy class, which is the abstract interface that defines how all the strategies will be implemented. Then, of course, we have the strategy, which is the concrete implementation of the abstract strategy. It contains the algorithm or the strategies that needs to be implemented. Now we have the context. The context is the code that uses a strategy. It invokes the algorithm for a particular business logic or a behavior that needs an algorithm or a strategy to implement. And of course, the usage is where we show how the implementation is done. The context is responsible for invoking the algorithm through the strategy interface without knowing the specific implementation details of the chosen strategy. Let's start with implementing the abstract interface. We're going to call it strategy, and then it's going to be implementing an operation. And then now we also have its concrete classes. We have concrete strategy 1, and then we also do another concrete strategy. Basically, these are like the algorithms or the strategy that the context will use to work. Now let's implement a context. A context on instantiation will take in a strategy, and then you use the method execute strategy to execute the operation method of whatever strategy that you have entered here. And it's that simple. Let's have 2 strategies. We have strategy 1 and strategy 2. We'll also instantiate a context, and in the context, we're going to pass in one of the strategies, strategy 1, and then run this context execute strategy method. It's now going to execute this strategy calling the operation method of the strategy that we have here. Let's take a look at the output code, and you can see right here it executed the strategy 1 operation. It printed out executing concrete strategy 1. And we can also pass another strategy to the strategy instance and then call its execute strategy method. The context execute strategy method, as you can see here, will call the passed in strategy, which is strategy 2 operation method. And the operation method is what print out the output executing concrete strategy 2. As you can see here, concrete strategy 2 operation method print out this information. The strategy design pattern helps us to implement different strategies or algorithm on a context or on a business logic, using its own method to call the operations of the algorithm or strategy without knowing specifically which operation or strategy it's calling. This video is part of a 20 hours Udemy course where we cover hundreds of real-world design pattern scenarios. Hello and welcome back to this session on template method design pattern. The template method design pattern is a behavioral design pattern that provides a way to define the skeleton of an algorithm in a base class, while allowing subclasses to customize or provide specific implementation for certain steps of the algorithm. The pattern follows the principle of inversion of control, where the base class, often called the template class or abstract class, defines a template method that represents the overall algorithm. The template method consists of a series of steps or operations, some of which are common to all subclasses and some of which may vary. When a client invokes the template method on a subclass, the overall algorithm is executed in a predefined sequence. The concrete operations are executed as defined in the base class, while the abstract operations are implemented in the subclass, providing the necessary customization or variation for those specific steps. The template method pattern allows for code reuse, encapsulates the common algorithm structure, and provides a consistent workflow across different implementations. It promotes modularity and maintainability by separating the common algorithm from the specific implementation of individual steps. Hello and welcome back. Let's take a real-world code example of a database query execution using the template method design pattern. And we're going to start by implementing the concrete class, and the concrete class will have a template method that implements all these methods, and the method shows the algorithm for executing query. And that first is connect to the database, run the query, process the result, and then disconnect from the database. And on this method, we're going to have the connect to database as a default hook, and then we're going to have an abstract method. The only important one that has to be implemented here, because it has an abstract method, is the run query. And then we have process result default hook, and then the disconnect from database. The first concrete implementation will be for SQL query execution, and it inherits the abstract template. It's implementing the run query and then also implement the process result. It uses the default implementation as shown in the other unimplemented hooks. So it only did for run query and then for process result. The process of connecting to the database and disconnecting to the database is left for the abstract class to implement. Then we have a Postgres SQL query execution that also implements the database query execution template, and it also implements the run query and the process result. And the process of connecting to the database and disconnecting from the database is left for the abstract class to take care of. So let's now run this code in the client usage. I'm going to start by initializing the MySQL query execution. I'm going to call the execute query method, which runs the algorithm of connecting to the database, run the query or process the result, and disconnect from the database. Let's look at these in the output. As you can see, it connects to the database, it runs the MySQL query, and then process MySQL query results, which for now has no result because the result is returning nothing, and then disconnect from the database. I'm going to run for the Postgres database, and for Postgres database, of course, I will initialize the database and then run its template method, which I'll pass the query that I want executed. So it's running the execute query, which is a template method. And then as you can see, it's connecting to the database and it's executing the query and disconnect from the database. To produce a form of result, I'm just going to add a return to the SQL query and also do the same thing for the Postgres query. So if you see here, the results, I'm just simulating it. So it connects to the database, it executes the MySQL query for customers, and then it gets a dictionary of the customers, and then it disconnects. The connecting and disconnecting is using the default hook. You use the default hook if the action is consistent across all the subclasses. And here also connects to the database and disconnect from the database. And then we have the query and then the result of the query. The template design pattern provides us a common structure for defining an algorithm, and then it allows its subclasses to customize the algorithm in the way that it suits its purpose. This video is part of a 20 hours Udemy course where we cover hundreds of real-world design pattern scenarios. The course is called Design Pattern in Python with real-world code examples. We showed via practical coding how design pattern is implemented in real-world scenarios like event manager, cache, database connection codes, document management code, creating optimized configuration settings, login frameworks, GUI framework codes, plugin systems, game development codes, payment gateway, document generators, computer graphics generation codes, financial model code pattern, resource pooling, object pooling in ORMs, website creation, database query codes, language translator, web application framework creation, banking system codes, organizational chart creation, file system, interpreter, menu system, text formatting code, authentication code, authorization code, API for OS, document management system, create proxies, event handling, middleware in web development, workflow system, undo redo functionality in apps, job scheduler scenarios, parsers, chart applications, drawing applications, notification system, distributed system, booking system, workflow management system, sorting algorithm, file compression utility, and many more. If you are really serious about your career in programming, you have to get this video. And you don't have to be a Python programmer to use it. Use the link in the description to get the best price for this course on the Udemy platform.